Okay, I have some images from the internet, which actually came from the television, I think, most of them. Some of them are not television things, but they are kind of interesting images, and what I did is I just kind of transcribed them onto the board here because when I'm using Learning Glass, I can't very well take these too easily and put them up there. Doesn't quite work out. So I'm not sure what would happen if I actually tried it, because this is already backwards. So I'd have to really put it up this way. I have to print it backwards and then put it up there. It might work, but I just didn't do it. Okay. So the first slide, or first picture on the slide, is what's your favorite season? It has 53%, 17, 17, and 13. And I just don't get what they did there. 17, 17, just wrong. Otherwise, I think it's okay. It looks like the 17 is the right size compared to the 53. I think 0 is here. Looks okay. 13 is pretty close to 17. A little bit less, maybe. I can't really tell. I think we're all right. So I think the only thing that went wrong there is someone just made this bar the wrong height. And we would check maybe that the sum of those percentages is 100. I think it is, because that's 34, that's 47, plus 53 is 100. So I think that part's okay. And over here we have apprehensions at the border, 165,000, 170,000, 192,000. This is happening 2011, 2012, 13. And honestly, 165 and 170, 192, percentage-wise, are very close together. And this 192 makes it look like all of a sudden in 2013 there's a huge jump. But actually the jumps here are, we're in thousands, 5,000 here, and this is 22,000. So the jumps are bigger, but compared to the total, you see where 0 is. 155,000 is here. If we had drawn those bars correctly and gone down all the way to 0, the things would look more like this. And you go, yeah, it's going up, but it's not dramatic. Here it looks like it's out of control, but in reality it's just going up at a consistent and not very large pace. So that's not putting a 0 in the wrong place. Underneath there, Obamacare enrollment, two different dates, 6 million, 7 million. The 0 point is definitely wrong. It's not 0 there. 6 million and 7 million, well, 6 would be 6 tall, and then 7 would be 7 tall. They'd be very much the same height, and that's not what's showing up because the 0 is in the wrong place. Here we have the cost of gas last year, last week, and now. Last year, last week, and so this time scale isn't consistent, so that's going to give you false conclusions. So what it looks like is the price of gas has been going up, and now it levels off. But this is only a week, and that's a whole year. So in a whole year, of course, you see some bigger increase than in 1 week. And plus, it's exaggerating the size of the change because 0 isn't here. That's $3, that's $3.50, that's 50 cents. It's not an enormous change, but you're zeroing in on just the change, making it look dramatic. And then, why would you do this? I don't have any idea. And then here's welfare versus full-time jobs. This is welfare. This is full-time job. And the idea here is we're trying to show that a lot of people are on welfare compared to full-time jobs. But this number is 108.6. And that's a 101, so I can't write it, sorry. 108.6. 108.6 and 101, they're almost the same number. This looks like this one over here is like 6 times as big as that. It's not, it's just a little bit larger. They're pretty much comparable. That's in other words, 0 is in the wrong place argument. And then this is a poll. It says, do scientists falsify research to support their own theories on global warming? Somewhat likely, very likely, not very likely. I don't see how that you can do this. These don't add up to be 100%. And it'd be unlikely that you would be somewhat unlikely, whatever. It would be unlikely that you'd pick two of those. So I'm not sure what they were thinking when they did that. And so maybe that's 61 together, and that's basically 60. So something's wrong. Maybe some typo happened. I don't know which one it would be. There it is. So that data can't possibly be correct because it doesn't add up to be 100. On the next page, we have some silly stuff. This first one is about statistics show that teen pregnancies drop drastically after age 20. And sure enough, once you're 20, you're not a teenager anymore, so you can't have a teen pregnancy. So it goes down to 0. So what? That's funny. Here's taxes at the pump. It says up to 20% of your gas bill at the pump can be taxes. The taxes are listed up here. This size here is not 20%. It looks more like a third, depending on how you interpret this. It's even more than a third of that blue bar. Maybe that blue bar goes all the way to the top. It could. That 383 could be all of this. If it is, then this is way more than 20% of it. And even if it isn't, then it's really way more than 20% of it. It's like the size of that is more like half of this bar, and it's more like a third of this bar. It's not 20%. So that those upper 3 tax bars were expanded so they could make the writing visible, but it makes it look like the taxes are a lot bigger than they actually are. And then over here, we have a pie chart with these numbers in it, 51, 43, 34. They're bigger than 100 again. So another small problem, something like this one. We're not sure. It says Americans who have tried marijuana, 34% in 1997. I think that was a poll done in 1997. 43% said they've tried marijuana last year. And then 51% said it today. I think they mean this year, not today, like today, just this year. This year, last year, so the percent of people who have tried marijuana, if you ask them today, this year, they tried it this year. If you ask them, maybe 51%, 43%, 34% for the fraction of the population in those 3 time periods that had tried marijuana. Of course, those aren't parts of a whole, so you don't make a pie chart. It's just ridiculous to do that. You would make a bar graph to compare them. And then, as I look at it, you can see how hard it is to compare those amounts. Even if a pie chart was appropriate, which is not, I'm having a hard time comparing 51 and 43 and 34. I'm not sure those sectors are the right size even. That's funny. And then we've got this dental anxiety graphic. It says 75% of U.S. adults suffer from dental anxiety. I don't know what these people are doing here at different colors. 2 dark people and 2 light people. That looks like 50% to me. I think that they should have colored something, one of these 2 center people or one of these outside a different color so that there'd be 3 of one and 1 of the other. This looks like 50%. One of these, 50%. So just inaccurate graphics. You see them all over the place. Take a look at the paper, or take a look at a newscast, or take a look at a podcast where they have graphics. And lots of times, the graphics have been adjusted so they'll fit on the screen, or so you can read the print, and that's distorted the size of the objects, or they put the 0 in a way off the graph to make the differences seem larger, or to make the differences easier to see on the graph based on the scale they're using. And sometimes they're doing it on purpose, and sometimes they're doing it just because there's a graphic designer who figured, well, we'll just make this a little more pretty. And more pretty sometimes means misleading. So that's the end of our section on misleading graphs. I think it's the end of chapter 2. I'll have to double check that, and we'll move on.